Badminton is a racket sport which involves a racket and a shuttlecock. It is usually played by two opposing players, known as singles, or by two opposing pairs, known as doubles. In order to score points, the players strike the shuttlecock using their racket so that it passes over the net and lands on their opponent's half of the court. A rally ends once the shuttlecock has struck the ground. To achieve this, many techniques and shot varieties were invented to make this game what it is today. In this video, we will be discussing the physics behind each type of shot. But before we go in depth, we will first see what happens when the racket hits the shuttle. When the racket makes contact, it exerts force onto the shuttle, in this case in a diagonal upwards direction. The shuttle then exerts the same amount of force back to the racket in the opposite direction, which is called the reaction force. This proves the Newton's third law. The shuttle is then pushed forwards. The first type of shot is the clear. This involves the player hitting a long shot across to the baseline on the other side of the net. By looking at this footage, it is visible that the speed of the shuttlecock decelerates drastically after a contact with the racket. A big reason why this happens is because of air resistance. The shuttlecock is especially designed to resist a lot of air, otherwise the players will not be able to hit it back because it is going so fast. According to ResearchGate.net, the coefficient of drag by the shuttle is 0.55 to 0.65. This is about the same as the friction done between rubber and concrete. The second type of shot is a drop shot, which is a short, concise shot that barely makes it over the net. By using this shot, the player is able to gain positional advantage. However, this shot must be done perfectly or else serious consequences may be faced. This shot can also be used to prove the law of conservation of energy. By using the formulas EP equals mgh and EK equals 1/2 mv squared, we notice that point A and point B have roughly the same total mechanical energy, thus proving the law of conservation of energy. We can also see that at the vertex of the parabola that the shuttlecock forms, the gravitational potential energy equals to the total mechanical energy. This is because at that point, the kinetic energy of the shuttlecock when going in vertical direction is 0. Additionally, since the height of the badminton net is 1.524 meters, the perfect drop shot will have 7.5 times 10 to the power of negative 2 joules of gravitational potential energy at the vertex of its flight. Thus, we are able to see that in badminton, the total mechanical energy stays the same throughout, proving the law of conservation of energy. The third type, and perhaps the most important shot, is a serve. The serve is a drop shot combined with the focus of not only grazing over the net, but also hitting as close to the service line as possible. So now, the player must serve so that there is enough horizontal force placed on the shuttle to make it across. The last shot, which is the most exciting shot, is the smash. It is the ultimate attack in badminton and is also the fastest shot in the game, with the world records recording up to 408 kilometers per hour. In this footage, we can see that the shuttle is going so fast, not even the camera can pick it up. It records as a blurred yellow line. Due to the high drag and air resistance, however, it is important to set the direction of the smash right so that the shuttle hits the ground before it loses too much velocity. Thus, the player aims for a straight darting smash that goes right above the net and down on the opponent's court before they can even react. In conclusion, badminton is a fast-paced sport that requires good reflexes and a solid understanding of physics. Although the players do not notice it, the entire game of badminton revolves around the concepts of physics and the interesting movement displayed by the badminton shuttlecock. This video is sponsored by Yonex. Get premium quality badminton goods today at www.yonex.com.